In this video I will show you 3 very small Matlab functions to get some set information, to read out the set labels, and to get the order number of one specific unique element label. These functions are themselves not very helpful, but they will be part of the functions I show you further down on this website. In the last video I showed that with such a little script I can read out the values of the variable number. Execute a script, and when I type xyval I see the value of the variable which is 1 and 1 for the unique element labels with the order number 5 and 7, which is boiler 1 and 3. But I would much prefer to have a result that looks like this. However, to transform this result to this result, I need to know whether 5 is the first or the second or the third, fourth element in the variable number. I can see it here now clearly, but of course we want to have it automatically. So Matlab somehow needs to know whether our dream vector will look like this, or like this, or like this. From the order numbers 5 and 7 we know, okay, in between there's one more element and it has the value 0, otherwise it would show up here. But we don't know whether there are maybe elements before that or after that. So I want a script, and I'll show you in a minute. I want a script where I can enter any set, and as an answer I get what is the order number of the first unique element label in the set, and how big is the set, how many unique element labels does it contain. Because from these two information I can derive whether the desired vector will look like this, or like this, or have any other shape or number of elements. So the first set I'm going to show you will give you these two information, and I have it written already here. It's called set info, and it works the following. It's a function, and I type in the name of the GDX file. In this tape, this is GAMS optimization, GAMS to MATLAB. And I type in the set from which I want to have the information. For example, D is a set. It contains boiler 1, 2, and 3. And I want to know what order number does boiler 1 have, and how big is the set. So I type set D, and as a result I get 3 and 5. 3, the first number in this vector, is always the size of the set. How many unique element labels does it have? And 5 is the order number of the first unique element label. We can double check this, for example, by executing this again, and get the list of all unique element labels. Then we see 1, 2, 3, 4, 5. Okay, 5. The order number 5 represents boiler 1. So that was already correct. And with this piece of information, we will later on store the value behind the 5 in the first position of our vector, and we will store the following values according to their order numbers. So we will insert a 0, and the next position will have a 1, and because the size of this set is only 3, we will then end the vector, and then we will get exactly such a vector. Well, how does the set work? How does the function work? As I said, you need a GDX file name and a set name. The set name will become the name of a struct, and then with the rGDX function we will read the information of this struct from the GDX file, and I store it on the variable struct. Maybe this is an easier way to show you. Now GDX struct is a struct, and if we continue, then we can have a look at struct. We see this is a set and has these values. And when we now check out the size of, or I could just show you, the information is 567. So here we see already all the information we want. First order number is 5, the size is 3, and with this function we get the size 3. That's what we read here and stored in the first position of our result vector. And the second information we want is the first order number of this set. So we just read the very first number of struct val, which is 5, and store it in the second position of the result vector. And then we have a result, set information, the size, and the order number of the first element. This function itself is not very useful, but it will be later on an important part of functions that can read, that can make the transformation from that can make the transformation from this to this. And we will also be able to make this for for example, 3-dimensional variables, like it is, for example, here. That's much more complicated, and we have different sets, 3 sets here, and we want, for example, to have this table, these numbers in Matlab without this number, and also in a nice form. And maybe we want to choose, does it look like this, or is it better to have it like this? So in functions to generate such tables, this function will be very useful.